helicopter development. And Airbus India Engineering Center is covering the full spectrum of Airbus Group development scheme, meaning that not only we're engaged on all the different technical competencies which are considered at engineering level for Airbus Commercial, but we are doing also the same for Airbus Helicopter and Airbus Defence and Space, meaning that it's an opportunity for you, if you are willing to do so and if you are selected for that, to be engaged for a lot, globally speaking, at the aerospace level. When I say longer journey, is that it's really an opportunity for you to consider that today we are going to launch plenty of new programs. You have certainly heard about the ZEROe and the decarbonization, hybrid new aircraft, new engine, usage of hydrogen, usage of electrical powered aircraft. We are working UAV, drones, new taxi, autonomous taxi. We are working on development drone of military and development of new products for military footprint. And all that is coming more or less at the same time. And that's the reason why we have a need to have a large number of competent engineers who are willing to engage themselves for. It's an opportunity for you because you will have a big visibility or clarity of what would be not on your development, potential development as engineers in the next 2 to 3 years, but I must say that for the next 20 years. And there is not so many environment or company which can afford that. Therefore, it's really important that if you are willing to engage yourself in this journey together with the major key player in to give you access to our Hello, I'm sorry I was disconnected. Are you able to hear me? Yes?
Yes, we can.
Sorry for the disconnection, but it's only temporary. For what an opportunity for you to be capable to as of now, even if you are already finishing and not if you are not finishing your studies, to get access in advance before you are part of the dynamic job market in the next 1 or 2 years, to get access to mentorship with recognized technical engineers from the area, will be there in order to not only give you access to some already existing projects who are managing at Airbus, but also to mentor you, to already put you in a concrete and actual job which will give you the access of what are the Airbus values, which are really made of ethics, team spirit, collaboration, diversity, all of that by giving you access about what footprint we have. And this is, I think, really when I'm looking backward when I was a student, really an amazing opportunity, because you will be able to be on board on all this potential development scheme in advance or largely before your colleagues will get access to that only when they will reach the job market. Therefore, consider it as an opportunity, looking at the diversity of the type of project we are willing to do, looking at footprint and the willingness from Airbus to develop a sustainable aerospace for the future, for the pure benefits of the people. Looking forward to have many of you applying to this program, and to get obviously the best talent, because as manager of this engineering center, obviously I'm looking forward for the best people. Therefore, I hope that you will have this with the and share information with our HR team and technical people. You will get the opportunity to appreciate what we are able to bring to you and what we want to get from you. Therefore, enjoy the day. Don't hesitate to challenge my team's member who will be there to present you the different project and technical environments. Don't hesitate to ask all the questions you need and you have to our HR colleagues in order to better appreciate what will be the advantage to participate. Really looking forward to join us in the next months with this program. Do we have the opportunity in the team to have any specific question? Consider that my speech was enough clear in order to introduce the event.
Yes, it was clear, Frederick, for setting up the context.
Okay, good. Therefore, enjoy all of you, because it's important, obviously, and definitely enjoy this moment, and really looking for a numerous number of early birds in the next months in a positive mindset in order to support our continuous development in India for our engineering center. All of you. Bye.
And thanks for joining us today. So moving on, now I would like to invite Nitin Mohan, Manager for Recruitment and HRBP Simulation and Physical System, to give you all the brief introduction to Early Bird Program and University Collaboration Initiative. And people who are joining online, please feel free to post your question in the Q&A session. So over to you, Nitin.
Thank you. Good morning once again to everyone. I hope I'm loud and clear and you can actually hear me, because the things I'm going to talk about in the next 15-20 minutes are going to change our perspective about early bird. It is going to give the perspective, our Airbus perspective about early bird, your perspective about early bird. A lot of things are going to change. So before we start, I have a question to everyone. I'm not expecting an answer, but a very generic question. How many of us go out in the market and to buy a two-wheeler, to buy a four-wheeler, and we just go and without testing we buy it from the showroom? I guess no one of us, because when we are doing a long-term commitment, because two-wheeler or four-wheeler is a long-term commitment, we just don't change it every 6 months. We definitely would like to buy the best one. When it comes to any job, why don't we think about the similar way? When we say that we want to join a certain company, have we tested the work environment of the company? Have we tested what does the team look like? How any company's values are, the work cultures, the ethics are? And that is very difficult when we have not worked in the company environment at all. Now, this early bird program is a win-win for everyone, not only for the candidates who have joined online today in the program, but for us as well. The candidates, the students know which type of work environment they are opting for, but also the company knows that what candidates prefer to know, what they want, what are their values, what are the candidates' values, do they meet the company values or not, where do we have to adjust, do we have to work more on the culture side, and so on and so forth. I'm going to go through a few of the slides which are here, and then let's talk about the early bird program. Okay, so today's agenda, we are going to talk about why the early bird program, how do we want to bridge the gap, what is the program all about, how the program roadmap looks like, and then the specific presentations from the departments. The airframe department, which talks about the complete airframe of the aircraft, the flight physics department, and the simulation and physical systems department. So as I said, why? So we have run a survey among the students as well as among the industry to understand what are the gaps today we are facing, what are the challenges today we are facing with respect to the onboarding of the students. Few of the major questions, few of the major challenges which were faced were that what do we are in line with the upcoming technologies like digital, big data, etc., etc. So a lot of students said no, they are not clear what the companies are. What company works into, whether they are ready for that or not. Another challenge was, do the theoretical knowledge is sufficient to solve the practical problems which industry is facing today? And which is a definitely no. Companies are facing the challenges there because you are studying in the best institutes in the world. You are gaining the best knowledge which is available in India. And you are understanding the most typical or most critical theoretical topics in your day-to-day curriculum. However, when it comes to the practical knowledge, there are certain things which are not taught in the institutes, and which not only the companies, the institutes also agree. And that is why one of the initiative which was taken was to educate the institutes, educate the students about what today any company faces, what are the challenges which any company faces, what are the practical issues when you come into a company, you have to withhold with. So these are few of the things, few of the challenges which were faced by both sides, students as well as the industry. I'll not go into all the challenges because I don't want to bore you with that. But when I talk about the other challenges, most of the challenges were on the similar lines. What we want to do with that? This was the why part of it. Then the next question came is how we are going to do work on this thing. I'll give you one small background of it. I have roughly 19 years of experience. I started my job in May of 2004. My first company was not very positive when I joined. I left the company in the small time. What could have been better if I would have known what I'm falling into? What was the company culture? How the company supports the development of any employee? whether I have proper progress opportunities, how the company will support me in overall learning. If I would have known all those things, my decision of joining any particular company would have been different. We call it informed decision. And this is what we are talking about today. We are talking about to bridge that gap between the students and the company. How we are going to do that? So as you can see in the slide on your screens, today university and any company like Airbus, we have a certain requirement on both the sides, and there's a big bridge which we want to make, which is going to help both of us. There are few steps which are going to happen, and I'm going to talk about in the next few slides. But the program objective is very simple. We want to teach the needs of the industry to the students. We want students during this mentorship, we want students to learn and focus on the core technical topics. And we want them to be industry ready by running some POC, proof of concepts, and pilot projects. This is on the technical side. How about on the behavioral side? We also want the students to learn the company's values, Airbus work culture, Airbus ethics, which Fred also mentioned in his talk. We want to show you how Airbus values its employees, how we focus on the learning of our employees, how we give them proper opportunity for development, we give them a progress path, how we support our employees from moving from X domain to Y domain by giving them proper support. So these are few of the things which we want you to explore and learn, and we want you to not to hesitate and talk as much as questions when and where you need. What will be the goals and objectives of this program? This mentorship will last 3 to 4 months, depending upon your availability and the people's availability at Airbus India. There will be 4 main sessions and few weekly feedback sessions as well. These sessions and the feedback sessions will help the students ready for the campus to corporate transition. You might have heard this C2C a lot of time from a lot of companies, but we have taken a step forward where we want to engage you at a regular basis, not on one-time basis, but at a regular basis to help you understand what is the expectation. What are the other few points? We want to give something back to the student community. We are not, this is, as we said, this is not a job offer. This is just a mentorship program to make you ready for the future. So we want to help the students to understand what is expected for any company. It's not only about Airbus, it's about the complete industry. We also want to increase Airbus and university collaboration by working together with you. We want to promote the application-based learning by giving you some practical examples, by practical issues, some projects which we have already completed or which may be running at the given time. And we also want the students to be introduced to the new trends and technology which are available in the market right now, which Airbus today is working upon. As Fred rightly mentioned, about few of the new initiatives which Airbus is working upon is something called zero emission, which Airbus has a target to launch the program by 2035 or make ourselves carbon neutral in the coming few years. Hydrogen as a fuel, we call it SAF, Sustainable Aviation Fuel, and few more initiatives. So these are the few core goals and objectives of this program. What does the program roadmap look like? As it is shown on the screen, there will be a selection process. First, you have to apply to the program. There will be a selection based on certain criteria. You will be onboarded. There will be onboarding session. Then there will be 4 major sessions, session 1, session 2, session 3, which will be mostly virtual. We'll see how, if it is possible to do it offline, that we will explore. The final session, the session 4, will be an office visit where we will ask you to come to office to see how we work, where we work, see the technical things moving here from one desk to another desk. We'll show you the labs around, how do we work on the certain programs, how do we deliver to our internal counterparts in Europe. And then it will be a program completion. This complete mentorship will be roughly 4 months. Based on the performance, we will ask you to apply for the campus placements, internships, and beyond at Airbus. And you all are aware that every year we come to your campus for placements. And I'm sure you might have received from the placement coordinators that this is a regular exercise which we do. What are the few major points here? So the students from third year are eligible for this. Few selected students will be onboarded, and then there will be 4 sessions, which session 1 will talk about basics, session 2 will talk about some application based learning, some doubts clarifications, question answers, feedbacks, project works, etc. And then the final will be project presentation. At the end, individual feedbacks will be provided, and we encourage you to ask as many as questions you can. This is something which I tell to everyone: no question is a stupid question. You may think that I will be a fool if I ask this question, but if you don't ask a question, if you ask a question, you may be a fool for 5 minutes. But if you don't ask a question, you may be a fool for entire lifetime. So do not hesitate. Ask the question. Be open as much as you can during these 4 sessions. This is for you. So these were the few points which I want to talk about. If moderators, if you have any question from the students, can I take it up?
There's a question: are students from 4th year also eligible from Ayush?
Well, what we understand that your degree course is going to complete in coming few months, and because this program is going to launch in couple of weeks, and it is going to run for 4 months, we don't think that you will be available to attend this mentorship program, because you will have your own placements or the job offers available. So it will be difficult for us and for you to accommodate this mentorship. And that's why we have opened this for only 3rd year students, because they will have time to work with us. Any other question?
Can we please get a clear idea on selection process?
Okay, so So the selection process is already set and standard. You have, I would not like to answer here. I would request you to explore with your seniors, your 4th year students, because they have already gone through the selection process once. This will help you to network also with your seniors and explore what they were asked in the selection process. It's not going to change. We are going to have the similar format this time as well. Okay, any other question?
Last is, what are the prerequisites expected from us?
What are the prerequisites? It's a very simple question basically. What we look for any candidate is 3 A's. What are these 3 A's? One is the attitude of the candidate. I don't have to explain what attitude means. You all have been hearing from a very long time. Aptitude of the candidate, that is the 2nd A. Can you understand the things quickly? Can you explore the things quickly? And 3rd A is altitude, the altitude to fly high. This mentorship program is all about flying high. And of course, it syncs also because we are Airbus and we fly. Any other question? No? So if there are no more questions, thank you very much. Thanks for your time, to listening me out, to hearing me out. If any more questions are there, please do send it to moderators, and I'll try to answer them in the later if I'll be able to connect. Or otherwise, we'll send it to your placement cells, the answers to these certain questions. Thank you very much. Over to you.
Thank you, Nitin, for the inspiring words. And I hope the students have got a very good picture of the expectation and a gist of what the company is all about. So moving on, we would like to walk you through the general overview of our departments participating in Early Bird 3.0 this year. So this year we have simulation and physical systems, airframe and flight physics with us as a part of Early Bird initiative. So to begin with, I would like to invite Rohit Verma, Head of Physical Design and Integration Team from Airframe.
Okay, thank you.
Thank you.
Good morning, everyone. So myself Rohit Verma, and I'm representing Airframe India department over here. So within Airframe department, we work on different skills and competencies. To start with, structural design activities, stress analysis, numerical simulations. Apart from that, we also work for system installation majorly. Okay. So in system installation, we work for electricals as well as mechanicals. But on this particular day, I'm going to discuss more about physical design integration. So this is the team which I am heading at Airbus in India. So within this team, so our teams are majorly involved on system installation. Electrical system installation is more or less regarding all electrical harnesses, electrical wires that you see, or sometimes you're unable to see because it is fully covered with the rest of the components. Apart from that, we also work for mechanical system installation, like you might have seen landing gear on the aircraft. So we work on the installation of these landing gears, the main landing gear and the rear landing gears. Apart from that, we also work on cabin design activities, like the installation of emergency equipment, placards. You might have seen a lot of notes once you enter inside the aircraft. We also work on the layout design for the aircraft, more or less, the cabin, the architecture, all those things. Okay. And last but not least, we also work on the integration. So once we design these aircrafts, we do the installation. We have to make sure these systems are fully integrated into the system in line with our design principles, more or less. Okay. So this is the overall overview what we do in physical design integration. So we normally call the PDI to keep it simple. And within this group, we are ramping up very fast, specifically on electrical system installations. Okay, so this is where we will discuss more in detail. I think we can ignore video since audio is not there. Sorry, we have some technical glitch. We are not able to share video because of audio constraints. Nevertheless, so while electrical wiring is important, this harness installation inside an aircraft. Typically, an aircraft's life would be somewhere around 40 to 50 years, and there are many factors which impacts the electrical wires or electrical harnesses inside the aircraft. It can be moisture, it can be failure of some of the attachment. Attachment is nothing but where electrical harnesses are mounted, and sometimes vibrations and even dust can also cause some system failures. Okay, and typically, we do modification of the entire aircraft throughout a cycle, because sometimes we have to do some retrofits also, because there are specific needs from the specific customers if they want to have some additional equipment inside the aircraft. So this continues regularly, and you might be surprised that typically inside one aircraft, the length of the electrical wire can be as long as 500 kilometers. Okay, so here you see the impact, the number of electrical wires, the length of electrical wires. We are responsible, and we are doing the installation of these electrical wires, design and installation of these electrical wires. And our major aim and the goal is to make safe and reliable flight with higher standards to make sure our aircrafts are airworthy. Okay, so we are fully compliant with all certifications and guidelines to make one of the safest aircrafts for our customers. Coming forward, so within electrical system installation activity, it's a dynamic team. So we work across various programs. So to start with A320, which is single aisle product family. Apart from that, we also work for A321, which is extra long range. We also work on the wide body for A350 programs. And typically for these programs, we work from design of the electrical harnesses and until the installation of these electrical harnesses inside the aircraft. And we work very closely with our counterparts and our colleagues all across Europe, so majorly the 4 NETCOs. And we work very closely with our colleagues in Toulouse, in France, as well as in Hamburg, in Germany. And these are our design offices typically. And apart from that, these design offices, we also work with MCAs and final assembly lines. So MC is a major constituent assembly, and FAL is final assembly line in Germany as well as in France. So the ultimate goal is to bring this bird to life, and we use significantly CATIA systems to design these electrical harnesses and making sure the installation principles are in line. So more or less, so whenever there's a new request for the modification from any of the carriers, so we need to come up with the new design solutions. So one of the example can be the airspace. So if I come forward, so this one, so if you see, it's a very fascinating cabin, airspace cabin. Whenever these requests coming from our customers, so we have to make sure they are fully compliant with the new design principles, and our aircraft is ready to fly. We typically design our electrical harnesses inside the CATIA system. This is how it looks like. And overall, at the end, in the bottom right, you can see the schematic. So this is how the electrical wires look like inside the entire aircraft. So this is only one section of the entire aircraft. Okay. Moving forward, so why it is our team is important. So typically the electrical power delivery goes from engine to systems. Okay, so it's a very complex network. It's more or less kind of a neural network of all electrical wires inside the aircraft. We work from systems to subsystems and the equipments inside the aircraft. And we have to make sure that our equipments are fully protected in terms of surge by providing grounding and bonding to the equipments. We have to make sure our aircrafts are safe against any of the lightning strike. So we have to work on the shielding as well. And in any case, we have to make sure that our aircrafts are having a plan B in terms of redundancy. We have to make sure we have redundant systems in place whenever there is a failure to make sure our aircrafts are fully reliable and safe. As I mentioned, so we have to make sure our flights are safe during the entire course of action. This is one of the most important requirement. And time to time, we integrate new ways of working because if you know, single-aisle aircraft is one of the oldest aircraft within our product family, and we have to continuously evolve. Continuously, we have to do the improvements within our products. So this is where you might have heard about digital design and manufacturing, DDMS, and services. So we try to integrate new methods, new ways of working to make sure we are able to support in terms of ramp up our single-aisle program, because we are getting a lot of requests and sometimes we are not able to cater because we have a lot of backlog. So we have to continuously make sure that our designs and our processes are as lean as possible to make sure we can manufacture as many aircrafts possible. At the end, so as a design office, we act as a key link between design requirements. So as soon as we get design requirements, then we go to installation, shop floor design. And finally, there is a loop how we can continuously improve our design methodologies. So the electrical system inside an aircraft is a function of a nervous system, because without this nervous system, it is unimaginable to imagine that we can really fly an aircraft. Okay, so now you can understand how complex this system is, especially in the race towards electrical aviation. So this is why it is utmost important that we make sure our designs are fully safe. So here you can see in the bottom right corner, the complex electrical wires, and this is what we do typically in a design office. Okay, so this is how it actually look like in a physical context. This is our team. So this is working on electrical system installations. So time to time we also have to make sure fun at work. Okay, so we don't only work on our typical projects. And I really invite you guys to please come forward and apply. Do come and join us if you want to be a part of this journey at Airbus in India. Okay, and hopefully we will be able to see some of you within our teams in coming months. Thank you, and I'm open for any of the questions you guys might have.
Questions? Could we get a few questions?
Yeah.
Okay. I'm just quickly going through. So simulation engineer, I will not. I will wait for others to comment. Okay. So in term, so there is a one question from Satyaki Mitra. So what might be the fields existing and emerging that company works on? So as I recently mentioned, so we work on the typically within my group on the electrical system installations. So we don't work on the traditional electrical systems only, but we are also supporting on the new technologies. As Nitin mentioned, we also work on the future programs. Okay, so we are not working on our existing programs only, but we are also working on something which will get into life in next 20-30 years as a part of research and technology. So some of them are typical examples how the fuselage of tomorrow will look like. We work on the fuselage of tomorrow. How the wing of future will look like. We also work on the wing of tomorrow. Okay, so these kind of topics we typically do work. And apart from that, in terms of I think the background, so there is no limitation. Anybody can apply typically, but typically we prefer people from specific streams like automobile, civil engineering, aerospace, even mechanical. Okay, so they are typical, so it will be easy for them to get adapt to our system. But nevertheless, those who have zeal to learn, who have right behaviors, and for sure we will be more than happy to welcome them. Okay. So there is another question from Prince. So project allotted will be domain specific, not necessarily. So there are quite a few people within our team who have joined from automobile, mechanical engineering, even from industrial as well. So as soon as you guys join, we give you specific trainings in terms of ramping you up on specific tools, specific domain knowledge. And once you are ready, you will be deployed into the real projects. Okay, so in nutshell, no specific constraint. Okay. Not really. So there is a one question: how does facilities in India work with the offices in Europe? Are these offices in India only for support? Definitely no. So in quite a few projects, we work as a multifunctional team. So we have a colleagues from Airbus India, we have a colleagues from Airbus Hamburg, similarly Airbus Toulouse. So we work together as a multifunctional team. And we are fully integrated in some of the specific domains that it is not kind of a support we give from Airbus India. So we work as a core team together as a fully transnational team. Okay, so I hope it answers your question. I think that's all. Any further? Very good question. That's all. Okay, so thank you. Thanks a lot, and I wish you all the very best. Hope to see you soon. Thank you.
Thank you, Rohit, for the presentation and answering the queries from the students. So moving on, now I would like to call upon Akshay Batwara, Head of Aerodata and Design, along with his team members, Arj Patel and Kiran Xavier from Flight Physics. So over to you guys.
Hello, good morning everyone. Myself, Kiran Xavier. I'm working with Airbus for the past 1.5 years with Flight Physics Capabilities team. So I hand over now to my colleague Earth to take us through Flight Physics as an organization.
Hello everyone, I'm Earth. I've been working with Airbus India for the past 2 years now, and I work in the aircraft performance team in Flight Physics. Let's begin to look at what Flight Physics is. So Flight Physics as one domain consists of several subdomains. The first one being aerodynamics, loads in aeroelastics. Then we have strategy and capabilities. Then you have mass properties, aeroacoustics and engine performance, flight dynamics, and aircraft performance. Now, each of these domains are sort of disciplines within themselves, and let's look at what each of them entail. So mass properties, this domain supports the sales and marketing by preparing weight guarantees for the airlines and ensures commercial guarantees are met for any aircraft. They also predict and control the evolution of aircraft mass properties throughout the design iterations that happen. They create mass models representing the latest known status of aircraft design, and they are used in multiple steps of a design iteration. For a more common example, what they do is also look at things like on-ground stability of aircraft, whether or not the aircraft is within the CG envelope during its flight and on ground, and such activities. For aircraft performance, I am from the aircraft performance team. So what we do is we assess the overall aircraft performance for an aircraft design and at all given maturities. So we have several design maturities through which the aircraft design goes through, and we look at the aircraft performance and see if it's met through each of these design maturity gates. We demonstrate compliance and airworthiness safety requirements with the EASA and FAR requirements that are given to us by the regulatory authorities. We also ensure that mileage payload guarantees to the airlines are always met. We also prepare onboard applications just like the FMC, FMS. A part of our job is also to prepare mathematical models for the overall aircraft performance and special cases like in-flight failure cases. For example, in a certain case, you might have an engine fail and you still want to know whether the aircraft can climb away safely or can reject a takeoff safely. This is what is done essentially by the aircraft performance team. I will now hand over to Kiran to continue with the presentation.
Yeah, thank you, Al. So the next subdomain in flight physics is the aerodynamics team. So aerodynamics as a team is primarily responsible for designing the external shapes of the various configurations of the aircraft and the various components of the aircraft, like the wing, fuselage, nose, tail cones, and they're also responsible for sizing and designing the various control surfaces like the high lift devices and the wingtip devices and so on. The aerodynamic team is also quite involved in designing the physical models and data to represent the complete aerodynamic characteristics of the aircraft. The aerodynamics team is quite involved in supporting the final assembly line and also in supporting the in-service requests that are coming from various airlines after the aircraft has been delivered. For example, if there is a minor damage to one of the lift-producing devices within an aircraft, the aerodynamics team is responsible to certify whether the aircraft is flyable or not under such a circumstances in an aerodynamic standpoint. The aerodynamic team is responsible for verifying and validating the aerodynamic models and the designs through internal tests and flight tests. The team also carried out rapid decompression studies and calculations for certifying both commercial and flight jets. The next subdomain is loads and aeroelastics. So as a team, we are responsible for calculating the forces, moments, and the accelerations that actually act on a rigid body model and a full flexible model of an aircraft configuration under extreme loading conditions in order to ensure a safe structural design margin. So such an extreme conditions can occur due to the following reasons. It can be due to a severe turbulence, it can be due to an extreme maneuvering situations, it can be due to severe grounded operations or few abnormal events like water landing, the one that we are familiar through the famous movie Sully, or it can be due to a tail strike or a belly landing and so on. So going further, the next theme is flight physics capabilities, which I'm also currently part of. So as a team, we are responsible in developing and maintaining continuous and efficient methods, tools, and solutions for all the other subdomains within flight physics. We also coordinate transformation and innovations across the flight physics by working on emerging competencies and state-of-the-art technologies. For example, surrogate models, machine learning, artificial intelligence, model-based systems engineering, DevOps, cloud computing, quantum computing, and so on. The next subdomain is aeroacoustics and engine performance, which is a relatively new team that is started within flight physics. So as a team, like, we are responsible to support the external noise certification of the aircraft. The team is quite extensively involved in assessment and validation of the engine models and the parameters in an acoustic standpoint of view. The team also carries out advanced CFD simulations using the state-of-art technologies like the lattice Boltzmann methods to estimate the various noise parameters to certify the aircraft. So this brings me to the conclusion of introducing or briefly introducing the various subdomains within flight physics as an organization. So with this, I now hand over to Akshay, team leader of aerodynamics team at Flight Physics, to share a few words.
Thank you, Earth. Thank you, Kiran, for giving an overview of Flight Physics team. Hello all, I am Akshay Batwara. As Kiran said, I lead the aerodynamics team in Flight Physics India. As my colleagues explained, we in Flight Physics work at the heart of aircraft design. As a flight physics engineer, we aim to deliver and optimize aircraft solutions at core of architecture. And with this, we enable the future of aviation. Whatever topics they have explained, we sometimes work on topics which are in service, but most of the time we work on topics where we prepare our future of aviation as we see it. As you may have seen and probably know, we work at the corest of the core competencies and hence look for technical expertise, innovation, and at the same time, the creativity. In addition, it's important to note that not a single person can design a whole aircraft. It takes a village to create an aircraft, and therefore, teamwork and collaboration with a very wide network is very, very important. And as Fred was saying earlier, and as Nitin said earlier as well, when we look for engineers who will join us, we look for these competencies. Your technical competencies obviously are very important. The education that you bring with yourself, your experience is very important. But at the same time, how you work in a team, what are your behaviors, how do you live our values, they are equally important. Finally, we in our team also believe in having a lot of fun. It's at heart of whatever we do. I personally love working here because I'm proud of the products that I work on. I've been here for 9 years and enjoying every day of those 9 years. In the end, if I have to summarize what we do at Flight Physics, I can truly say that we truly pioneer the sustainable aviation for safe and united world. We bring people together and at the same time have a lot of fun doing it. Thank you. Any questions for me or the team?
Thanks for joining today, and thank you, Art and Kiran, for the presentation. So, at the end, I would like to invite Nitish Kumar, Head of Physical System Architecture Team from Simulation and Physical System Department. So, over to you, Nitish.
Thank you. So, good morning, dear colleagues, esteemed professors, and my dear students. Okay, let's start. This particular session would be a bit longer because there are a lot of job descriptions that we have shared, as well as I think this was the first department where we started early bird concept. So let's start with the basics itself. As you can imagine, making an aircraft is really complex process. There are hundreds of components thousands of subcomponents, so many suppliers across different geographies, working across timescales, and everything should come and fit together in a perfect way. That's what aircraft making is. During this phase, we will have different people involved. The top program objectives would have their own needs. The project managers would drive things in their own way, and the engineers would pitch their ideas. If we cannot balance any one of them, the product will not be sustainable. Thus, this whole concept of making an aeroplane follows a principle called systems engineering. Okay? This concept is applied across different industries, but it is well understood in the aerospace sector because it follows a simple logic. It starts by, how do I go back this one? Okay. It starts by a top level objective, what we call as CONOPS, concept of operations, and then we start breaking down things and reach the atomic scale. Once we are there, we start implementing things, okay, and start putting it together and testing at every phase until the final product is ready. To give you an example, a top level aircraft function looks something like this: move the aircraft, carry passenger, manage things. These are then broken down under, say, move the aircraft, control the movement and stability of the aircraft, ensure FMS or surveillance are managed properly, and so on. These are then further broken down. Let's take an example. Control stability of an aircraft. Now, stability can be controlled in different manners. You can control the altitude, you can control the attitude, and so on. Deep diving into attitude, one of the ways you can control attitude is by controlling the lateral movement. And you can see so on and on. This is how you start breaking down the things. To give you a flavor, there are almost 250 to 60 aircraft level functions and closer to 400 lower level functions. Many engineers would work on each of them either in parallel or together and overlapping with each other. That's why systems engineering is very important. One project that I would like to demonstrate where some of you might work with us in future, we have a requirements from what we called as our guiding principle, certification specification, CS25 for large airplanes. And the requirement says any catastrophic failure should be extremely improbable. And it doesn't result from a single point. But we are engineers. What does improbable mean? So what we do is we then quantify it. We say the probability of any catastrophic event should be 1 divided by 10 to the power 9. So 1 in a billion. And there must be redundancy built whenever we have some systems designed. Okay? So this is the logic. Now, how do we prove it? So look at this fighter plane. This is Ambala Air Base, northwestern part of India, and see what the flock of birds do to the engine. Okay, so this event is called as a bird strike. It's never one bird that strikes, it's always a flock of birds. And it's a very common form of damage that can happen. The idea is not to avoid bird strike, but to design the plane so that we can tolerate it and land safely. And we do it in the following way. We use the concepts of models. Models are nothing but approximation of reality. And we can have physical model, DMU as it is called, behavioral model, mathematical model. This particular problem we solve through physical model. We create a physical model of all the systems that exist in an aircraft, air conditioning, electrical, flight control, and so on, and superimpose that. So this is how the entire model for different systems look like. So please just taking a moment to appreciate the work of so many engineers who have built it together for many months. So this is how it looks. What we do next is look at where bird strike can happen and then superimpose them. Once we do this, we perform an analysis and create something called as a dossier, which is then evidence of verification that we have met this particular requirement. So like this, you will have many other projects, but this is just an example to give you a flavor. Okay. Now, as we go forward, for those of you who are aware of systems engineering as a concept, what we want to do is parameterize all the things and create model-based systems engineering. Imagine you have an Excel sheet and you have a lot of texts and formulas written, but having them all linked together so that you make a change in the value and it impacts everywhere else. This is what we want to do at an aircraft level. So that if I change anything in my physical part, it affects my function and it reflects which requirement will not be met at a click of a button or in a very faster way. Then we have multiple models and we use them for multiple purposes. Let's take the example of first flight clearance. Some of you would imagine that a first flight that any new aircraft takes, it has to balance a lot of other things. We have to take care of safety. We have to take care that the aircraft is mature enough before we fly it. Have we factored all the customer needs? Is the pilot trained? And whatever we have designed, is it manufacturable? So balancing all that is the need. But we cannot physically make it and then realize that it is going to be changed or it needs some other changes. It is too expensive. So we use models and we use a way to test them called platforms. In Airbus, what we have is we have different kinds of frameworks or platforms where different maturity levels of models are tested. To give you one example, if you have very high level ideas, if you have some research mindset, we use the top left platforms that we have that you see on the screen. But if you have a bit more mature idea, say you want some changes to be made to air conditioning systems, then we go and look at the design platforms. Okay? Similarly, on the top right corner, you see that is a full-fledged training simulator that we have in Airbus, and it looks something like this. This is in Toulouse, south of France. Okay, this has all the hardwares and it is very realistic. But you can imagine only the most mature models, when they come together, we test them here. Any flaw, any fault will damage the hardware or the wiring inside, so we have to be very careful. Thus, the other platforms that you see are ways to ensure that only the most mature network goes forward. Okay. To summarize, we have lots of models. We integrate them together to understand how models would behave together at an aircraft level that leads to our virtual first flight. This gives us confidence when we actually fly the aircraft. Okay? So this is the role of platforms, frameworks, and models team. Then this is the era of what we call as data science. If I'm not wrong, half the students who are here should have some interest or passion towards it. But what we need is data science together with aerospace or any core engineering domain. And that is a perfect combination. What we do here is very simple. Any flaw that happens or any fault that gets detected is what we call as diagnostics. Imagine you going to the doctor and doctor diagnoses your diseases. But what we want to do is not be surprised. We would want to track our health of the aircraft proactively. Imagine doing your periodic health checks to measure the, triglycerides or some other biological terms. So this is a way to find out whether I am healthy or not. The same concept applies to the aircraft. And we do this so that we can detect faults in advance. We have a more reliable equipment or product, and we catch potential catastrophic events even before they show signs of appearing. Okay. And we do this in two ways. Look at the first current way. Once we find a fault in a component, product, or design, we then go and maintain it. But when the maintenance is done, the aircraft is on the ground. So a very simple thumb rule for airlines: when aircraft is in sky, it makes money. When aircraft is on ground, it loses money. So no airlines would want this downtime. What we are proposing or what we want to do is monitor the continuous remaining useful life estimation. So basically try to see where there are sensors that give data that show signs of degradation and have periodic preparation in mind. This way the downtime is further reduced. Okay, so this is the concept of predictive maintenance. Our ultimate aim is to have a digital twin where we have, sorry, I'll skip this one, where we have a direct connection between the actual aircraft and the aircraft that is existing on our computers. Okay. Again, I'm sure a lot of students follow, what is that? Iron Man. So imagine having the suit of Iron Man and Jarvis telling you, proactively what is the health of your system. Okay. Avengers, sorry, that was the word I was looking for. Aditya, why don't you go and explain this slide?
Yeah.
I'll change it if you want.
Yeah, sure. Perfect. So I hope I'm loud and clear. So hello everyone, I'm Aditya from industry team from Airbus India. So probably Nitish rightly mentioned about the remaining teams and how we all are connected towards the system engineering part, how we all are into system and simulation and physical system. So over here, industrial is also a system. So what right now you have learned about is the product. The product is aircraft over here. Now consider how a product is manufactured. So in order to manufacture an aircraft, you need a facility, you need a layout, you need a plant, you need resources, you need process. And considering all of this stuff, it becomes an industrial system altogether. Now, in this slide, you can see that there are two videos. I'm not sure whether you're able to see the videos or not, but if yes, on the left-hand side, you see a video of an actual aircraft, how it's produced. And on the right-hand side, it shows how a factory of future would look like. So for example, now let's consider that we as an individual want to set up a factory to produce XYZ. It could be aircraft, automobile, pen, or as difficult as aircraft or as simple as pen. Now, if you directly buy a land, if you directly start construction on it, and at the end of the day, after investing so much capital investment and operating cost, you see that the requirement is not fulfilled. Does it add any value onto the real production system? The answer is no. So what we do over here is, first of all, whether the project is greenfield, that means we have to start from scratch, or whether it's a brownfield, where we have to optimize the existing flow. That is what we simulate, we optimize, we analyze, and we look towards the methodology, how we could increase and make our industrial system efficient. So maybe we can press the next.
Just press next.
Right. So on the right hand side, it's just a glimpse of a video. You can probably just have a look how the factory of future could look like compared to how the actual production process looks like. So you see on the right hand side, we are modularizing the stuff, and we are digitally planning, and we are digitalization of the industrial hangar processes and product is being done over here. So you can see over here how the factory and the processes are something which has been shown in the virtual end, and the actual positioning and actual stuff of manufacturing happening on the left hand side of the video. I'll just go to the next one. So in order to do simulation and in order to predict the performance and to optimize the process, what we do in simulation is first of all plan, then validate the system, and third one to optimize the system. And as this is a feedback loop, so we test and we implement it into the real actual production process. So if you are saying that in order to achieve our rate 60, that is throughput of 60 aircraft per month, we can actually simulate and we can justify that these all changes needs to be in order to reach the required rate. And then we implement it in the actual factory, which helps us in first time right concept, in achieving the first time right concept. Now, there are certain sub-teams inside industrial, out of which I'll take a few over here. The first one being industrial flow simulation. So now we have heard about, we read about, or we spoke about the factory of future. We spoke about the optimization of process. We have spoken about the stuff which will be required in order to make sure the actual implemented process is better than the existing one. Now, in industrial flow simulation, we look into the macro level of a plant and we try to analyze, optimize, and
study and implement the stuff which has been found out throughout the studies. In order to do flow simulation, there are three stuff that is called PPR, where first P refers to the product, that is an aircraft, fuselage, or anything which we want to manufacture. Second one being the process. The process refers to the process which is used in order to manufacture an aircraft or a product. Third one is resources. Resources are something which are consumables, which are used in order to manufacture an aircraft. It could be cranes, it could be AGVs, it could be operators, it could be jigs, it could be fixtures. Now, taking all these three PPR, along with certain inputs such as how the plant layout will look like, how the production plan will happen, when the first product needs to go, from the logistics standpoint of view, how the flow needs to be done, how the inbound logistics will look like, how the outbound logistics will look like, when the supplier part will come. And we try to model and simulate a factory or an industrial asset. And then we try out to find out the results, which could be such as lead time, takt time, throughput of the system, resource utilization, bottleneck identification, efficiency, flow efficiency, capacity utilization, and we study this logistics. So after we get all these results, we try to understand how we could improve it even further. And as you see, it's a continuous improvement loop. Then we send this input back into our model, and we try to optimize the areas of improvement and identify the bottlenecks accordingly. Now, moving to the next slide. So in the previous one, we have seen how, from a macro level perspective, we can improve and we can see the industrial system as a bird's eye view. Now, throughout my study in industrial flow, I understand that in order to achieve certain target, I need to have my cycle time or my takt time as X. However, is it actually possible to achieve those processes in the given stipulated time frame is something which we do it in IDV, that is industrial DMU, which DMU refers to digital markup. Now, what are the sort of stuffs which we do over here? First one, we create the layout, we design the concept layout, we even design the actual layout. Second is, we study the MBOM, we understand which could be the make and which could be the buy part, how the breakdown of EBOM will look like, how the breakdown of MBOM will look like. Third part is how we do the manufacturing process flow. So in order to manufacture a component, whether it's an aircraft, it could be phone, it could be pen, what should be the processes and how the processes should look like, how the critical path would be, how these processes are segregated across the different value streams of the processes or of the life cycle. Third, the next one being ergonomic simulation, where we actually see and we identify the effects of ergonomics, the fatigue analysis, whether the posture of a person would be fine in order to perform certain tasks, and if there is something which is possible in order to improve so that the worker efficiency and the safety increases. Along with that, there are other studies as well which we do, that is designing objects and fixtures, validating them, simulating them, and looking how we could improve the existing process. We even do robotic study where we see whether the robots are possible, whether we could use robot in order to do certain operations, whether we could optimize certain stuff, and we could improve the quality of the welding, riveting, drilling by using robotics and so on. So this is what the IDMU does. And what do we get benefit out of this? First one is we increase our production throughput. So for all the people probably who don't know, was not from industrial manufacturing background, throughput is jobs produced per unit time. And second is production cost. So we reduce the cost which is incurred in production. Third is we optimize the process planning time. We can actually support, we can suggest the feedback to the designers, because in design we can make a flying car, but in reality we know that right now it's not possible to create a flying car. So whether the designer has designed something, it is actually manufacturable or not. So this is called as DFME or DFMA, Design for Manufacturability and Assembly. So through this, we give the proposals for design change back to the designers so that we form a product which is actually manufacturable in the right quality and which could be achieved with the first time right concept. And last but not the least is the time to market. So we try to reduce the lead time as much as we can, so that we could launch our product ASAP, and we could reduce the time which it takes to launch a product to the market. And probably now over to you, Nitish.
So if you do a Google search about Airbus, probably this is the latest thing that you will find. Or if you are following Airbus, you will realize that we have announced that we will focus on sustainability, reduce our carbon footprint. And one of the ways to do that is to relook at how our fuel systems is. Today we burn hydrocarbons, produce carbon dioxide, and now we want to explore how liquid hydrogen can be used as a fuel and release only water vapor. Of course, there is end-to-end cycle and concept, but our first focus is on proving that this technology works, and then we take care of the entire footprint. Many of you who will join Airbus and stay for a decade or so will probably see and contribute in these kinds of engagements. So this particular slide talks about future outlook. There are many things we don't know how to design. And this is where your role in the university really helps us. You have the freedom to experiment, and we would want to learn from those experiments. I'll give you 2 examples in the next slides. What you see on the top left is a propane gas burning, and what you see in the bottom right is a hydrogen flame. Please notice that transparent thing that you see actually has a flame. Now, all our safety is based on visual aspects. So imagine there is we have a liquid hydrogen pipeline at the airport, and then there is a leakage which catches fire. All designs are there that visually sees fire and then it triggers something. So we'll have to think of new ways of sensing these fires, either through thermal sensors or something else. And then that is why we are not so sure how the aircraft would be. Okay. Second example is leakages. All fuels are imagined as liquid droplets falling on the ground. But unfortunately for us, hydrogen leaks in a different way, leaks upwards. So if you have a pipe which is going on top of another hydrogen pipe and there's a leakage, well, we have to relook, we have to rethink. And this is where we will need fresh eyes, not bogged down upon how legacy used to work, and you really bring this value. Okay. Now, summarizing, in order to really have a good start at Airbus, all you need to do is focus on your core strengths, which is your engineering fundamentals. Once you have joined Office or Airbus or any other company for that matter, you will get absorbed in projects, deadlines, team members, other things, and you may not get enough chance to go back and brush up your basics. So now this is your strength. You have the books, you have some more time in front of you. Go ahead and make sure your engineering basics are strong. Second one, there are a lot of subjects that are not taught at college or are just few chapters in college, especially the different aircraft systems. If you really want to devote your career on aerospace, please look at those systems, and I've given some examples there. Subjects like systems engineering, or rather concepts of systems engineering, are equally important. There's a website called INCOSE, International Council for Systems Engineering. You can refer that. And finally, combining these core skills with all the modern things, big data, data science, analytics, text mining, that combination is perfect for us. But most importantly, all this you can develop. But if you have passion for aviation, I think all this will automatically come. So build this, and then we look forward to welcoming you in Airbus. Okay. Thank you, everyone. Yes, open for questions and answers if you have. And I'll give it to them. This is the last one. Okay.
Thank you, Nitish and Aditya, for a very descriptive and engaging presentation. You have rightly shown bigger dreams for the students and also sown some seeds of thought for them.
Thank you.
Thank you.
Okay.
So I'll read a question which we got. The usual idea of development is working on full stack apps, websites, etc. As students, we have very less exposure to aircraft technology. How can coming into aircraft industry affect my candidature in future? If later on, if I want to switch to a generic development profile.
I'm guessing the student's background is computer science or something like that. Full stack is what? Computer science technology, right? So I'll try to answer it in this way, and let's see. Our product is aircraft. You may come from hydraulics team, you may come from electrical background, and you may come from IT. The product remains the same. In order to manage so many designs, so many parts, we have a lot of IT products that need computer science background, that needs a lot of automation, that needs a lot of configuration management. Thus, information technology or information management, cybersecurity play a vital role. So while engineering is important, there is a whole lot of other fields where we need colleagues from software engineering, cybersecurity, which is a big risk nowadays. So there is a place for everybody. So please don't get a message that the only way to prosper in Airbus is by working on the engineering domains. If you are good at computer science, IT, cybersecurity, there is a whole different field for you to get engaged in.
The question, can we make a simulated model of the entire path of an aircraft and train it to go that way by ML learning? So that can we save money given to pilots?
Yes. I think drones already do it. There are a lot of fact that this algorithm will be heavy because you not only have to look at the shortest path, you have to look at wing direction, you have to look at the other aircraft that are flying. And one thing you cannot replace is that human factor. What if there is a flight in distress and it has to break the rule? How does it react? So it's a very good guide, but then there should be some mechanism. So it's a very good idea. Yes, it can be done. I think we will start with drones or UAVs, probably switch over to freighter or the cargo planes and then implement it. But the idea is really good.
Maybe you can also add about the autopilot facility which we have and how it is also.
Yes, so we are trying to. So if you think about aircraft industry today, do you think pilot actually flies the aircraft? It's actually pilot who tells the machine what to do and the machine who actually flies the aircraft. There's a lot of computer behind it. There's a lot of algorithms behind it. And we are trying to ease the life of pilots by introducing furthermore assistance, and machine learning plays a vital role there. Is it to the extent where the entire aircraft can be managed by that? Probably we are a bit far away from that. But slowly, step by step, one module after another, this is the attempt. We have already achieved auto landing and auto takeoff. And by building these modules, we can have the entire flight plan assisted. And yes, machine learning can play a big role there. Okay.
And other question, how important is the knowledge of operations research, production management important in the job? What is the job profile related to it?
You answer that. It's your area, no?
Yeah, so the question is, how important is the knowledge of operation research, production management important in the job, and what is the job profile related? Okay, so as we said, our team name is Industrial Systems. So whatever falls under the perimeter of manufacturing an aircraft, whether it is macro view, whether it is micro view, whether it is ID view, whether it is simulations, whether it's design, whether it's modeling, it could be any other stuff. It could be robotics, it could be ergonomics. There are plethora of options over there. So in order to do everything, so there are certain skill sets which are required. First, for example, as you have said about OR, so I believe that you have some OR knowledge, so you probably might be aware of CPM, PERT, critical path. You'll be aware of cycle times, takt times, activity diagrams. These are something which helps you in order to define the processes. And without process, you cannot manufacture and create an industrial system, or you cannot manufacture an aircraft. The next one which was said about project management. So you see the amount of workload on each of these processes is so high that the takt time is of, it's not in seconds or it's not in minutes, it's in days. Sometimes in hours, sometimes it's in days. So the amount of workload that is so high. So without project management, or without the understanding of complexities and to understand the dependencies of one system into another, and having this project management knowledge, you cannot make sure that the entire system is becoming leaner. And at the end of the day, you need to make sure the system is more agile and you can deliver the aircraft faster.
Maybe I'll add one point if it's okay. Imagine you are going to a shop because you want to buy a laptop and the guy tells you that, yes, great, come back after 3 months and I'll give it to you. That is exactly the situation which the head of Air India or head of Indigo is facing. They come and ask us, I want to buy a plane, and we tell them the backlog is 6,000, come back after a year or two and then I'll give you your 200 planes. Now imagine doing a business like this. And what is the reason we can't do it? Because we are unable to produce it that fast. Now, if we are able to produce it that fast, Airbus wins, Indigo wins, any airline, it's a win-win for everybody. But there is a bottleneck, and in this case, manufacturing is a bottleneck. So there's a whole new universe waiting for you to improve that. Operations research, all the things Aditya mentioned is extremely important.
Interesting question. Can we mix some other gas which has a smell and color with hydrogen to detect the leakage?
Yes, it's done in LPG today. So LPG is butane. I forgot from my college days of 15 years ago what was that gas. It was there's a gas that is mixed, and that's the leakages we use to detect. It can be done. Yes, it's a solution, but remember. Helium. So it's a non-combustible one. Okay, so there are multiple ways to look at it. Your thought process is in the right direction.
Just to add on to the complexity, that hydrogen is cryogenic in nature. It be used as fuel. And if we add some other gas or any other gas into it,
correct. So
the calorific value of both the gases
correct.
Not match.
I was about to say not only calorific value, the ignition point, the amount of energy it will need to liquefy. So there are other vapor pressures it created.
So as you rightly mentioned, these are some thoughts on the
yes. So whoever raised this question, it's the right thought.